Hi guys, Mr. Johnny here. This is not a box of matches. This is a turn signal relay. A blinker relay as I call it. Which is conveniently hidden inside this matchbox temporarily because the plastic enclosure is drying up at the moment. It's a very nice little circuit board. 3 by 4 centimeters. Does not take much space. Uses 555 as you can see. Bunch of passives. Uses N-channel MOSFET as a switch because I have implemented a bootstrap here. You can see the diode there and this capacitor, that's a bootstrap circuit, works excellent. Very simple layout. Now this is gonna be installed on the motorcycle. Now one thing you have to understand, whether you're installing this into any vehicle, is it a car or motorcycle, scooter, whatever, any vehicle, there is a high vibration there. So if you're gonna install some components without physical support, they're gonna break loose sooner or later. Like this TO220 package. You can see I fixed it with a screw and nut to hold it in place, because otherwise, even when in this position when it lays flat, eventually it will rattle loose. Ask me how I know. Now I'm gonna go install this on a bike, show you how it works, and then I will show you the schematic. At the moment I have another relay installed, which does not really work all that great, because it's designed to be used with incandescent bulbs, and I have LEDs all the way around. And that relay is kinda, you can imagine that it powers itself through the actual lamp. Is it a light bulb, incandescent light bulb, or LED? So LED is much less current, higher impedance effectively, and it behaves rather weird, and I hate that. This one works extremely well. It does not matter what the load is. Is it a 50 watts? Is it a 0.5 watts? Does not matter at all. Okay, let me demonstrate how the relay that is installed at the moment works. I flick it on right now. First of all, it blinks a little bit too fast to my liking. Second of all, you saw how much time it takes for it to go off, to go on, rather. I don't like that. That's why I have installed, I'm gonna install that circuit. Now, let me do that. Now let's do the same with that new relay. The old relay is right here. It also has a little circuit board in it. I glued it. I'm gonna show you later, but when we turn it on, it's pretty much instantaneous. You still see a little, like, not very bright blip, for the very simple reason, the bootstrap. Again, this is a quite low power stuff, even though it's very bright. Not only on camera, but in person too. Basically, it's still a high impedance load. It still takes a bit too much time for the bootstrap capacitor to charge properly, so the MOSFET will be fully on. But once that little glitch is gone, which takes a fraction of a second, it's nice and it's good and proper. As you can see, I can turn it on and it does not turn on in the same state because it's not synchronized in any way. It's a free running oscillator with a switch on it connected to it, high side N-channel MOSFET switch, which works extremely well, and the little disadvantage that it turns on in the random state is not really all that much of a hassle for me at all. It works and I'm happy with it. Alright, now the schematic. The schematic looks like this, very straightforward. Typical S-table oscillator using 555, driving this transistor, which when turned on pulls the gate of the MOSFET to ground, effectively turning it off. But what happens at first? Let's say you don't have any of these. You have only this, which you can see, which is not blocked by my hand. When you apply load, the current will flow like this, through the diode, through the capacitor, through the load, charging it up, and the voltage will be voltage across the capacitor, turning the MOSFET on. Then you can turn it off, of course, by turning this transistor on. See, very easy, makes perfect sense. Capacitor recharges every time the transistor switches off. And this resistor, this diode and resistor is not only polarity protection but as well drops a little bit of voltage, because I read the datasheet for 555. It says the maximum voltage is about 15 or 14 volts, and I do have 14.4 at full charge, so a little bit too much. I don't want to write on the absolute maximum value, so I put the diode there and the resistor, and it drops a little bit off, which works well. Plus it gives me a reverse polarity protection, so nothing will happen if you put 0 volts here and 12 volts here. The only way you can fry this circuit is when you put 12 volts here and ground here. This way the body diode will conduct and fry the MOSFET. But otherwise, if you're gonna say connect the load properly but put 0 volts here and 12 volts here, ain't nothing is gonna happen. Everything is gonna be safe and sound. So that's that. Thanks for watching. See ya.